My name is Tzvi Sherman, and I'll be demonstrating, with Epic's Action RPG project, how I use some of Unreal Engine's built-in audio system and blueprints to create procedural, spatial, and dynamic sound design. Starting with the most basic forms of ambience, I tackled two-dimensional audio layers such as wind and low cave rumble as a sound bed for the general area. I began by creating a sound cue with asynchronous looping layers. So each time one layer's loop begins again, it's playing against a different temporal location of the other loop, producing subtle variation such that each permutation of both layers together doesn't sound exactly the same. Furthermore, I've introduced an enveloper node for each layer with looping pitch and volume curves that loop at a different length than the wave player, so that even within a single looping ambience layer, there's asynchronous playback, providing even more variation without using additional voices. Next, I introduced spatial sound emitters for static objects around the level, like these braziers. These sound cues look similar to the ambience bed, except that each layer of the fire sound is hooked up to a modulator node, so that each torch sounds slightly different, ensuring a stereo image if the player can hear more than a single instance at once. This cue shares an attenuation asset, so that I could adjust the inner radius and fall-off distance as I tested the level, and it would propagate to all instances without manual adjustment. In order to have more depth to the ambience, I created sound cues for randomized, modulated one-shots. These included distant drips in the cave, cricket chirps, and frog calls. Focusing on the frog croaks, for instance, I created a call and reply by having a random node pull a variation, then applied slight modulation and followed that with a concatenator node that would pull again from a random selection of other variations with slight modulation at a delay to act as a reply. To add more variety to the ambiences and help bring the space to life, I added a system through which the randomized one-shots could be spawned around the player in 3D along the X, Y, and Z axes to simulate coming from the in-game world. This way, rather than tying the sounds to manually placed actors, the sounds would be procedurally spawned, thus being both a more efficient workflow and also having the benefit that these elements would play from different locations within this playthrough as well as future ones. Creating a new spherical collision component in a new blueprint, I first entered the construction script so that I could set the sphere's radius to a public variable. This would enable me to resize the boundaries of the sphere collision from the details panel and provide the flexibility to reuse the script for other ambient sound in specific locations throughout the level, like having water drips in a particular area or clusters of crickets. In the event graph, the system turns on via component begin overlap for the sphere. After checking if the overlap is the player, and not some other actor like an enemy NPC, I set a timer to call a custom event that will trigger the ambient sound cue. When the overlap ends, that timer is cleared. In order to avoid repetition every set amount of seconds, which would be a dead giveaway that the sounds are spawning at specific times, I set the timer to pull a random value from the minimum and maximum time options and re-triggered this timer in order to pick a new interval each time a sound is played. To play the sound at a random point around the character, but retain control over where, relative to the player, the sound is spawning, I needed access to both the player location as well as their rotation. So I retrieved the player location, then normalized the get actor forward, right, and up vectors, and created public vector variables for the minimum and maximum distance ranges. Breaking those values into constituent axes, I can generate some random distances along them using the random float in range nodes. By multiplying these values with the getActor vector nodes, I can add the resulting vector to the player's location, spawning the sound above, below, in front of, or behind them. Finally, in order to have this blueprint be fully flexible and reusable, it needs to also trigger should the player be spawned within the collision. Currently, it will only activate when the player first overlaps. So, using the event begin play, I checked for what actors are overlapping this blueprint and narrowed it down by the blueprint of the character pawn. Checking the elements of the resulting array with a for each loop node against the getPlayer character allows me to branch and then execute the timer system. Moving on to animations, I opted to add new notify events instead of playing the sound directly, as that would not only give me more control over what sound is played, but it also allows for greater flexibility with conditional statements, as well as calling the event from multiple animations. While I tagged animations for things like weapon swings, Foley, and vocalizations, I'd like to focus on footsteps since they have an added layer of complexity. Placing an animation notify event flag at the footstep frames within the animation, I can pick up the custom event in the event graph blueprints. To identify the surface material that the player is stepping on and play the appropriate footstep sound, I used a line trace by channel that draws a line from the player's position directly downwards and returns the value of the physical material. Using a select node hooked up to a spawn sound attached populates the slots with selectable sound assets, so I chose this route instead of, say, a switch on surface node. As a safety measure, I've added a branch to make sure the return value is true before playing a footstep, because if the player was stepping over a hole or jumping, I wouldn't want a footstep sound to play. Using a print string node, you can see the readout of the physical material, as well as hear the change in the surface playback. To glue these footsteps, the ambient one-shots, and the static actor sounds together, I placed an audio volume to encompass the area and allow the sounds to be sent to a common reverb. Finally, the positioning of the listener didn't completely sound natural, so I created a child component to the third-person camera that would act as the listener and could have its distance between the player character and the third-person camera be adjustable. Essentially, I have the blueprint calculate the difference in world location of the spring arm and the camera, then normalize that value so that it can be multiplied by this float variable, which I've called % towards camera. And the resulting vector is subtracted from the spring arm's location, and then that new location is assigned as the listener. Here it is, visualized in-game with the camera mesh. I found that roughly 40% distance between the two was a sweet spot for still hearing the sounds as the player is close, while maintaining a third-person camera perspective. Thank you for watching the entire video. If you'd like to see more of my work, my portfolio is located at tzvi.audio/games, and there's a clickable link in this video's description.